All right, so this is going to be an introduction to something called equation of tangent lines. So we're essentially moving from the slope of a line to the equation of the whole line, but we'll get to that in a second. So right now I just want to recap this notation here, which again is read as f prime and represents what we call the derivative, which is just fancy slope. So if you totally got what we did in class yesterday, there's no need for you to watch this. I'm just going to go through and figure out how to do the slope of this equation the fancy way. If you want to skip to the point of the video where I start to do this problem, feel free to do that. Otherwise, right now, all I'm going to do is describe how I get the derivative here. So the derivative has this notation. And again, all it really means is the slope of this thing. This thing is a line. So if I graphed this in Desmos, the slope of that line would be 7. So I already know my answer. So the whole point of me showing you this is just the easy way, well, an easy example of the long way of how to find slope. So the equation for slope, which we've gone over a few times, so I'm not going to do that again here, is this. So f of x plus h minus f of x, that's the gap in the height. So what you're finding there essentially is this distance from here to here. That's what this little formula tells you. And then the denominator is h. So that's my limit function equation essentially, right? That's the place I'm going to start. So the first thing I'm going to find is f of x plus h. And again, if you were here yesterday, you know that if I ask you to find f of 10, all that means is we're going to plug in 10 into machine f. So whatever my equation is, we're going to replace x, because that represents input, with 10. If I wanted you to find f of m, all you would do is go to the f function and replace all your x's with m's. So your equation would be this instead. But all I want you to do is replace every x with x plus h. So that's step 1. Replace all your x's, which stands for input, with the input that I'm curious about, which is x plus h. So I'm going to go to the equation, and every time I see x, I'm going to replace x with x plus h, and then I'm going to distribute. So now that I've put x plus h in, I'm going to get this out. So now this is going to replace the top part of my first function. So basically the short story there is anytime you're asked to find the the derivative, you're going to replace all the x's with x plus h's and do some algebra to simplify it. So this is my equation. I forgot a 7 over there. I'm going to adjust that. Okay, so then I'm going to use subtraction, and then f of x, so minus sign, f of x is here. It's interchangeable with 7x plus 1. So wherever I see f of x, I'm going to replace it with 7x plus 1, and then just a little h downstairs, because again, that's what the formula tells us. So plug in x plus h into the equation. I always do that on the side. Replace what you get into the top part of the equation, subtract the original function, and then divide by h. And now it's just a matter of, simplifying things. So I'll just duplicate this, and I'm going to distribute that minus sign. So minus sign to here, and a minus sign to here would give me that. And then if you notice, a bunch of stuff is going to cancel out. That way it's really clear on the key. 7x's will cancel out, the 1's will cancel out, and now you're just left with the limit as h approaches 0 of 7h over h. But the h's cancel out here, so the limit as h approaches 0 is not significant because the h's just, are canceled out. So this has no bearing on the actual answer. So the total answer is just 7, and voila. So we know that the slope of this equation is 7. Okay, now that's a lot of work for doing something that you obviously already know the answer to. So the whole point of doing this kind of thing here is to get the answer when we don't know what the slope is by just looking at it. So new kind of thing here. All right, so this says if the slope of the tangent exists, meaning if you have a line with a slope, then the equation of that tangent line. So now I'm not looking for the slope of the line, I'm looking for the exact equation of that line. And if the point that's on that line is this point here, C stands for some random number. When you plug C into the equation, that's your y. So remember, this is just xy. Then you can write the equation in point slope form. So this is literally just the point slope version of the equation of the line. So instead of doing y equals mx plus b, that's one version of an equation. We're not going to use that one. We're going to use this one. So f of c is just the y value of the point. X minus c, c is the x value of the point. Okay, so it looks a little complicated, but don't be scared. It's going to work out. Okay, so step one. Find the slope of the tangent line at any point. So here's what they want us to do. They want us to find fancy slope. So again, I'm going to do the exact same equation that I did above. F of x plus h minus f of x all over h. So I'm going to find f of x plus h by replacing all of my x's with h. See, replace the x with x plus h here and here. Then I'm going to simplify, not this side here. There's nothing to do here. Leave that alone. We're going to square this out. So remember, x plus h squared means multiply x by itself. And we did this a few days ago, or yesterday maybe. X times x is x squared. This is an x and an h. And this is an x and an h. So essentially we have two of them put together. And lastly, h squared. And they're all plus signs. So this turns out to be that. Okay? And we'll practice that more. The more of these you do, I promise you, they will start to get easier. So I'm just going to replace that. So here you go. I took this, which represents x plus h. Now I'm going to subtract x squared plus 1. And again, f of x is interchangeable with this. So there you go. And I'm just going to distribute that minus sign right now. So that's going to be a minus x squared plus 1. And that minus sign will distribute that to here. So it'll be a minus 1 as well. So minus x squared minus 1 all over h. And now good things should happen. So the x squareds are going to cancel out. The 1s are going to cancel out. And I've got the limit as h approaches 0 of 2xh plus h squared over h. And again, the nice thing here is that this h is going to cancel out a bunch of stuff. So now, if the h cancels out an h from here, I'm left with 2x. And the h is going to cancel out one of these h's from here. So h squared is 2 h's. Canceled out with one of those. It's going to be this. And remember, now we've got to do the limit. So it's a long procedure to do like a lot of stuff. And there are shortcuts here, and I'll eventually teach them to you. But right now we got to go the long way. So replace x plus h here, simplify it, subtract the original function. Lots of things should cancel. And then hopefully even more things cancel so that h is no longer the denominator. You really don't want 0 to be downstairs. And that does. H will get rid of here, and we'll get rid of one of the h's here. So now we're at here at this point. And now if h approaches 0, then this will just tend to 2x, right? If h is approaching 0, then if it ends up being 0, this will go away, and you're just left with that 2x. So the short story here is that the slope of this parabola is 2x. And what I mean by that is, you've got a parabola that looks like this. There's a slope here, a slope here, a slope here, a slope here, and all those are different slopes. So this equation should help me get the slope of each of these lines. This curve has an infinite amount of tangent lines that we can draw, so this equation will help us shortcut that infinity a little bit, okay? All right, so let's see what the other questions are. Sketch the tangent line at 1, 2. All right, so x squared plus 1 is a parabola that's been shifted up 1. So I'm just going to graph that really quickly. So my parabola looks sort of like this. U shape starting at 0, 0, that has been moved up 1. So instead of the parabola living here, it's here. All right, so sketch the line at 1, 2. So 1, 2 is here. There's the tangent line. So now we have to find the slope of the tangent line at 1, 2. All right, so I'm going to take my equation, which is y equals 2x, and I'm going to replace the x with that. So our slope is 2. 2 is the slope you get. And by the way, it's just a coincidence that this is the slope, that it matches the second value. To get the slope of the tangent line of any of these, you're going to take the equation that you got from whatever this was, using this fancy slope equation, giving you another equation. Whatever point they give you, you're just going to take the x value of that and substitute it into the equation. And when you do that, that will be the slope of that point. And if you can tell, it's like an up 1 over 2 situation kind of here. That's your slope. All right? So if somebody said to you, find the slope at x equals -2, well, -2 is over here somewhere. So if somebody told me to find the slope of that, I would take the equation that I got from part A, replace the x with -2, and the slope would be -4. So essentially, when I give you a point and you use the slope equation from part A, any point I give you, you just take the x value and sub it into the equation, and that gets you your new slope. Okay? So when somebody gives you a point and you have the slope, you can write your equation in point slope form. So we take our, and this is like y goes with y. So I'm going to take the y value of the point, change the sign, equals the slope, x goes with x, and there's your equation. So let me do that again. Point slope form, this is the generic version of point slope form. Everything that is not typical in an equation is going to be replaced. So like when I mean that by that is like the y1 is going to be replaced with a number, the x1 is going to be replaced with a number, and m gets replaced with a number. M stands for the slope. So the slope of this line, any line, is given by this equation. So if somebody says to you, take -2 and find the slope there, you're going to take that equation, replace x with -2, get your slope. And then the structure of the equation is that whatever x and y value you have, you're going to replace the x, you're going to pair the x's together. So x goes with x, change the sign. And the reason for that is we've got a minus sign in the equation and another minus sign. So minus minus is a plus. Okay? And it looks, and I'm not going to do this, I'm going to show you how to do this again tomorrow, but -2, 4, it looks like the point. So I'm going to give myself a little point. -2, 4, and I'm just using that, I'm eyeballing it really, just so that, make it easier. -2, 4 is here. So if x is -2, it looks like the tangent line goes through -2, 4. So again, this is the x, this is the y, and when you're writing the equation, all equations start with y. Y goes with the y value, but change the sign, so that's -4, equals m, that's the slope from here, x, then find the x value, change the sign. Okay? All right, I'm going to do this one more time, a little bit faster. Okay, so step 1, we need the point. The easiest way to find the point is to take the number and plug it into the equation. So 3/4 is the x, and I know that because it gives me the x. Then I'm going to replace x with 3/4. 4 times 3/4 is 3, plus 1 is 4. So 3/4, 4 is the point. In order to write an equation in point slope form, I need the point and I need the slope. And I'm not going to use m, I'm going to use f prime because that's the notation. Okay, keeping it real simple. I know what the slope is, but I'm going to do it a little bit faster. All right, to find the slope, I'm going to use my equation. Here's the equation, f of x plus h minus f of x as h approaches 0. Replace x with x plus h. Simplify that. That's going to be 4x plus 4h plus 1. Then I'm going to take away the original. So I'm going to distribute that minus sign. So it's going to give me minus 4x minus 1, again, over h. 4x's cancel out, 1's cancel out, h's cancel out, 4. So the slope is 4. So the equation is y. All equations for lines always begin with y. Y goes with y, change the sign, so that's this y here. Change the sign. Y goes with y, then the m. M is the slope, that's the thing that we just did here. Oops, I should do m. The slope is 4. X goes with the x. Whatever this is, you change the sign. So negative 3/4. All right, hopefully that makes a little bit of sense. The big picture is anytime you have a curve where you have a line that you don't know where it's going to go through, you need a point of intersection. Sometimes I give you that point. And if I do, then all equations will have a y goes with y, x goes with x kind of component, and you'll just need to figure out the number in front. And you get that number in front, the slope, by doing this fancy new slope formula. All right, hopefully that helps. And if it doesn't, we'll recap it again tomorrow.